I'm Dave Kiefaber with Milliken. I'm the Midwest Region Manager. I'm based out of Indianapolis, and I cover the entire Midwest, so I have 14 states. And as I said, I work for Milliken. Probably most of you in this room haven't heard of Milliken. Is that accurate? If you lived in the southeast part of the country, everyone's heard of Milliken. Milliken is one of the nation's largest specialty chemical and textile companies. And so we still have, it's one of the only companies left in the U.S. that still has textile facilities producing product here in the U.S. We're also an international company, and you can see our facilities around the world. And these are some of the products. We're in the, as I said, specialty chemicals. We make clarifiers, dyes. We make high-performance apparel for the military, athletic apparel, fire retardant uniforms, and then we also are big in carpeting, commercial-grade carpeting. So a lot of the square carpets you see in airports and commercial buildings, chances are that's Milliken product. Recently, Milliken formed an infrastructure group and acquired some new technology, and that's what I'm part of now. I've been with Milliken a year and a half. Prior to this, I used to be involved with precast bridges, so some of you may have heard of Conspan. I used to be involved with Conspan bridges prior to this. And so here's some of the industries that our products are used in. And I'm mainly going to focus on two today, but we get involved in municipal transportation, erosion control. I'm sure the stormwater people get involved in that. So one product is we make a carbon fiber wrap. None of you guys are structural guys, right? Okay. So this is used to repair reinforced concrete structures. If you've got corrosion going on, you've lost some of the tensile strength or steel area, you can go in and use carbon fiber wrap to help strengthen that. And you can see building columns, bridge piers. We actually use it to line pipe, some pipe materials. We also recently bought pipe wrap. Has anyone heard of pipe wrap? That's high pressure pipe repair, external pipes, gas mains, force mains, where you go in around the outside and put material around the outside of it. And then we make a product called concrete cloth. And this is, I'll go into this a little bit more detail, but this is a product that can be used to line ditches, slopes, channel slopes. We also repair culvert inverts with it, and I'll get a little bit more into this, but this is kind of a neat product. The technology comes from the UK, and it came out of research done. It was developed for the war in Afghanistan, and the people that invented it patented it, and then they've expanded out with applications with it. So with the concrete cloth, it is a geocomposite fabric that's embedded with cement powder. And so it comes in different thicknesses. You can see CC5, CC8, CC13, that's millimeters. So CC5 is 2/10 of an inch, and then the CC13 is a 1/2 inch. And I've got a sample. This is a cured sample of it that's already set up. So it comes in a rolled form, like you see here, just like a geosynthetic fabric. And we have two types. We have a large bulk roll, and we have portable batch rolls. And you can unroll this material and use it. One use for it is culverts. And so if you have a culvert like this, a metal culvert, where structurally the culvert is in pretty good shape, but we're starting to see deterioration due to abrasion and corrosion in the invert. If you catch it early enough, you can go in and just put a new wearing surface in and extend the life of that culvert. And so you can see down here, you can see we're just starting to see pitting in that. And so these are this is where you can use this product for a new wearing surface. And so you can see they've lined it transverse to the flow and then longitudinal to the flow. And then once you wet it, it turns hard. You get 5,000 psi concrete surface.
What do they feel with it on the edge?
So on the edge, they use an elastomeric seal on that. And this is mechanically attached, so they're using screws to attach it. It's hard to see, but there's screws down here every 12 inches to mechanically attach it to that, and then we seal it. And you can see how we shingled it, so we make sure the shingles are downstream. So this is what a lot of DOTs do. they'll pave the bottom with concrete or asphalt, and that, you know, can be fairly labor intensive. In my state, Indiana, they actually have a detail where they want you to put mesh steel down and form it up and pour it, and that can get fairly costly and time consuming. So here's a project we did in Butler County, and this was twin 72-inch diameter metal culverts. And with metal culverts, most of the metal culverts or any metal piping that was put in the 60s and 70s is at or near the end of its life. Most metal is not really meant to last beyond 50 years, and so we're seeing that all over the Midwest. Midwest is a big market for metal culverts. So here you can see they're placing the concrete cloth fabric. It's very easy to cut. You can cut it with a utility knife obviously before it cures and sets up. And here, and you can see the screws they use to attach it. And they're lining it, and they're overlapping it 4 inches. And then they just they had it dammed up to prevent water flow from going through, and then they hydrated it. You can either spray it with a hose, or in this case, they just opened it up and let the flow go through. This will set up underwater, and this can even set up in salt water. So there's another shot of it, and then they seal the ends of it. Another application for this could be underneath bridges, the slope walls under bridges that sometimes erode. You'll see them, a lot of times the DOTs will pave those or put riprap on them. And this was a project with the North Carolina DOT, and it was a slope wall that was eroding. See how it looked? So I don't know if there was riprap before that, or maybe they just didn't do anything and just left it like that. But here we unrolled the concrete cloth fabric, and then he wetted it, and now we've got a concrete paved slope wall protecting that.
Frost effects from it?
I'm sorry?
Any frost effects?
We have done freeze-thaw testing with it, and we get very, very little material loss. There's a ASTM test for freeze-thaw where you go through like 200 cycles. And so we've had, some of this has been put up in Canada too, where you get the heating from the soils up there, and you know, winters are 10 months of the year. So no, it'll move. This is a flexible material, so it'll move, but we get very, very little material loss.
If water gets underneath there, does it come up as a big sheet that pull up as a big sheet, or?
It could, and when you install this, all edges need to be trenched in 6 inches. So we try to make sure we don't get any water underneath that could cause undermining, because that could happen. So this was an application. This is just a roadside ditch project with the Pennsylvania DOT. And you can see along the road there, it looks like they've got an erosive coarse material. And maybe they tried riprap and it just, you know, it washed out or it was undersized. And so this is the other shot's on the other side of the road. So there's 2 roadside ditches. And then the maintenance crews came in. You can see how they're trenching it in at the edge of the pavement, and then they're just lining that ditch with it. This is really meant for maintenance applications, not typically for new construction. Though we have seen this used in around oil refineries, those containment berms, spill containment berms. We've lined those with it. I think I have another shot. There's another shot of it after it's been wetted. So I mentioned concrete cloth is a repair product when you have minor deterioration of the culvert. If you have this situation, this is a structural repair. This is either replacement or structural rehab. And you can see the invert is gone on both these. And so with metal structures, the ring stiffness of that pipe is what's resisting the load, and it also depends a little bit on the adjacent soil to help contain that. But if you lose material conductivity here, eventually that is going to start to deflect because its ring stiffness has been compromised and its ability to resist those loads. And so this is where we would use our other product, our Geospray product. And it's a geopolymer material. And most of you have probably not heard of a geopolymer. And where we're using it right now is in storm and sanitary conveyance applications, piping applications, manholes, junction chambers. This is an acid-resistant material, so we recently lined some sludge tanks in Tennessee with it. In Europe, they're using it on tunnels and bridges. We haven't got there yet with it here. But the main market for it here in the U.S. is pipe rehabilitation. It's a centrifugally cast material. And so we've got a sled with a nozzle on it, and the sled runs through inside inside of it, like this, where it centrifugally casts or spin casts the product. So basically what we're doing is building a pipe inside the hose pipe. So the hose pipe acts as a form. This is a structural material, so we designed the thickness to handle the loads, assuming the hose pipe is currently not supplying any load or will not, especially with metal. So we assume in time with metal that it'll be rusted and gone. So we can line concrete pipes for this, metal pipes, steel. And the folks here that are remote, if you have a question, feel free to stop me and ask.
How small will pipe be lined with this?
So it does require manned entry, so the minimum is 36 inch.
What's the thickness?
The minimum we recommend is an inch, but we've gone up to 3 inches thick. So we've done some structures under 100 feet of fill where our calculations determine we need a 3-foot thick lining. The typical thickness we see is 1.5 inches to 2 inches is the typical. So I'm going to talk a little bit about a geopolymer since most of you have not heard of it. When you think of a polymer, you may think of a plastic material, a polyvinyl, a polychloride, a polyethylene. This is not a plastic material. It is a cementitious material, and as such, it has the benefits of a cement, the workability, the physical properties, and the service life. But what we end up with is an engineered stone. So it has the same chemistry, similar chemistry as you would have with a quartz-like material or stone material. And so, for those of you who are familiar with Portland cement, we know that Portland cement is made from calcium silicate, and they cook that material. They take limestone, they cook it, make it into an ash, and that helps form the pozzolanic binder. You mix water with it and aggregates. This material is made from aluminum silicates, and so it's fly ash from coal plants, furnace slags, and then we add microsilica and small aggregates and other natural pozzolanic material. But the difference is when our material reacts with water, it forms a long chain, a polymolecular long chain of material that's all covalently bonded to each other, as you can see here. So it forms a long string. Unlike Portland cement, when you add water to it, the water basically just attaches to it, and everything is in suspension. It hardens, but it's really not bonded together. It's just in suspension. And that's why if Portland cement gets any heat applied to it, it'll start to break up because the water evaporates, and then the molecular structure starts breaking down. This material is also heat resistant, in addition to being acid resistant. And for those of you who are interested more in the chemistry on this, I do have a white paper that describes it, that was written by one of our chemical engineers. So in comparison, you mentioned seeing this used before, and a centrifugally cast material has been around for a while, but typically what was being used is a Portland type material. And you've probably seen shotcrete used. And so there's still some agencies in bigger diameters that are still they're putting steel mesh down and applying shotcrete material. Typically that's a Portland cement material. And so if you're in an acidic environment, you're going to have the same problems with the Portland cement being attacked. But you can see, compared to Portland cement, some of the advantages. Strength-wise, we have 2 to 3 times the flexural strength. Our compressive strength tests around 10,000 psi at 28 day, very high acid resistance, and then it has very good abrasion resistance. Our material is called Geospray, and it says sustainable, and that's because over 50% of the material comes from post-industrial waste products. products that would normally be landfilled. So like I said, the fly ash from a coal plant, the slags from a steel furnace. And so we also have a lot lower carbon footprint than Portland cement, 80% less CO2 is given off. So this is considered a green concrete or green cement. The other advantage too is for those of you who work with cured in place, sometimes styrene can be an issue, the smell or the fact that it could get into your receiving waters. And there are some DOTs, Virginia being one of them, that does test to see how it impacts the pH of water. So this is an inert material, so we don't have any issues environmentally with its use. So I have these sheets available, but you can see the physical properties compared to conventional Portland cement mortar. And the big one too is in storm application is abrasion resistance. And there are DOTs that pay close attention to that. They want to make sure that it has good abrasion resistance when you're dealing with culverts that have very coarse bed loads going through them. So you can see the material loss is less than Portland. Another advantage of this material is the fact that it is a highly reactive material, so it will rebond with itself. And when we're lining a pipe, the question was asked earlier, what is your typical thickness? Usually it's 1.5 to 2 inches. When we're going through and putting in a lining, we usually will do a 3/4 inch thick lining. Let that set up, and this material does set up very quickly. It sets up in 3 hours. Let that set up, and then if we have to do, we come through with our second pass. If we were doing that with Portland cement, we know at the interface of those two layers, we'd have a cold joint, correct, right? We'd have a cold joint, and then we know that would be the weak point in that cross-section. This material will rebond with itself, so we do not get a cold joint that forms. And this slide here demonstrates that. The bottom here, the cylinders on the bottom are Portland cement cylinders that were poured on a 45-degree angle, and then at different intervals. You can see day 1 through day 28. They came back in and poured on it, let it cure. If we broke those cylinders, provided or put them under a compressive load, they would always break along the cold joint, and that's what we're seeing here. With our material, as it rebonds with itself, we do not get a cold joint, and so you can see up here, you can see where that line was in some of these. It just broke wherever the shear failure was within that cylinder. So why is that important? So you have the confidence of knowing if you have to do several layers, you're going to have the same strength properties across that entire section. You're not going to have to worry about a weak point in that. Does that make sense to everyone? I'll mention that it's a green material because of the low carbon footprint and the fact that we're using industrial waste products that normally would be landfilled. So most of you deal with sanitary sewers, and we know how hydrogen sulfide gas gets formed in through the aerobic breakdown of the material and the effluent. That gas collects on the pipe wall, and then the bacteria on the pipe wall lining break that down further. That basically it oxygenates the hydrogen sulfide gas and forms hydrogen sulfuric acid, and that's what attacks the Portland cement. So during the generation of Portland cement, you get calcium hydroxide molecules. They react with the hydrosulfuric acid and form gypsum, which is water soluble, and that's what dissolves the concrete. That's why concrete just dissolves over time. Our material, we do not have calcium hydroxide molecules, so we don't have the same chemical reaction that occurs. And this is a test we recently did. This is, we took some cubes, Geosprays at the top, Portland cement at the bottom, and following the protocols in an ASTM test, which the test is not listed on here, but basically it's an 84-day test. You put them in, we put them in a 7% hydrosulfuric acid concentration, which is a pH of about 0.9, so it's fairly acidic, or very acidic. And you can see after 84 days, we just had some minor discoloration and surface deterioration. With the Portland cement, we had over 50% material loss, and basically we have the aggregate left and a little bit of binder holding it together. So with our material, we do design it, and assuming that it is a thin-walled tube with uniform lateral pressure, and this is the formula we use. I don't normally put this in unless I have structural engineers, but
That doesn't mean anything to me.
yeah, me either. But we do need to know what the elastic modulus is and the loads on it. We take into account the ovality factor, but we do solve for the thickness here. This is the formula we use. And so some of the inputs we need, what we would need from you is the depth of cover, the shape of the pipe, is it out of oval? That affects the safety factor. What is the soil? We need to know the shear strength of the soil. And then if we're shallow enough and affected by live loads, we need to know what type of material is over the top of that. And then at the bottom you can see we rely on the elastic modulus, Poisson's ratio, and the flexural strength. So a question I get frequently is, what is the service life? And I'm going to pass around a sample. I think this is 1 3/4 inch lining that we took from a pipe. And what you'll notice as you look at that it's denser, it's less permeable than Portland. It's almost ceramic in nature when you look at ceramic cement. And so with that material, the Corps back in the 90s, the Corps did some studies on different culvert materials, and what they did is they reviewed durability studies that were out there. I know Ohio had a big durability study in the 90s. A lot of DOTs looked at materials and how they performed and what their service life would be considered. And so they did this review and found that concrete pipe has a service life between 70 and 100 years. That is concrete that's not in an acid environment. And so with our material, we feel we should have that similar, at least be able to say 70 years. Knowing what you now know about the benefits over Portland, we could even say closer to 100 years, even in an acid environment. And then the other question I get is the Manning's End. So if you felt that surface, it's a little rougher than smooth concrete that comes out of a pipe form. So we think it falls within a range of 0.012 to 0.015. We have done projects where we could not increase the Manning's End in sanitary sewers, and so we will go in and spray it and then come back through and hand trowel that to make it smooth. So if that's critical, we can do that. Any questions on that? So this is what a lot of DOTs currently do for culvert rehab, the slip lining. And this is one under I-65 in Indiana, south of Lafayette. And a lot of times looks like they could go with a little bigger pipes than this is by about 30% reduction.
Yeah.
Yeah. And in this case, the loss of waterway area may be offset by the improved Manning's End with an HDP lining. And that's true in outlet control, but in inlet control, what matters most is the opening size and the inlet loss coefficient. So if this was in inlet control most of the time, this could cause some impacts upstream. So we are the material producer, Milliken. We do not apply the material, but we currently work with a company called IPR, Inland Pipe Rehabilitation. And they are the nation's largest full-service rehabilitation company. And by that I mean they do everything. They do cured in place, they do slip lining, they are the nation's largest pipe burster. They also get involved in spiral wound applications or methods. But 90% of what they do is cured in place. But when they get into the bigger sizes, and I'm talking 48 inch and above, they found that spraying this material is more economical than cured in place. And with regard to the cost of it, we do have some pricing that shows, and I'll show you a chart here in a minute, but at about 42 to 48 feet, 48 inch, we're cost neutral with cured in place and slip lining. It's when we get above that then we become more cost effective. The other advantages are to less exposure from weather. If we are working in our culverts, for instance, and we know rain is coming in, remember I said it takes 3 hours to set up. So once that material is set up, we can just remove our sleds, let the rain come through, and then get right back in and continue spraying. The pipe can be wet, we just can't have flow going through it. So it's very easy to work around weather, that's where you're getting rain and runoff into your structures. The other benefit too is it's less disruptive, and by that I mean our working footprint is relatively small. We basically have a box truck, as you see here, and all our equipment fits down a standard 2-foot diameter manhole opening. And so, for instance, if you were lining a 6-foot diameter pipe and you were using cured in place, we know we would have to at least have a 6-foot opening to get those bags down if we're wetting out on site. With ours, we don't have to worry about pulling cones or digging shafts. Everything can fit down that manhole. And as far as the types of pipes we get involved with, we can do any shape. We've done egg-shaped, arches, ellipses, horseshoe, rectangular. We can do up to 500-foot lengths. And diameter-wise, we talked about it being manned entry, so again, that's at 36-inch. So we start at 36, and it says 180, but we're getting ready to do some 15-foot culverts for the Ohio DOT. Those would be hand sprayed. And then we can deal with pipes that are out of oval at over 10%. We can very effectively deal with bends in pipes, dips in the profile, or changes in elevation. And then material-wise, you can see we've dealt with stacked stone sewers, brick sewers, shale rock sewers, so any kind of material, because basically we're just putting a new pipe inside it. We don't have to have adhesion with the hose pipe. Basically all we have to do is stick to it until that material sets up, and then it doesn't matter what happens to the hose pipe after that, because we have a new structurally designed pipe inside it.
Vertical applications for manholes, how thick is that? Sort of something thicker.
Typically with manhole applications, when we're down about 25 feet more, it's 2 inches, inch and a half to 2 inches. We're talking, the Chicago Water Reclamation District has some 10-foot diameter shafts that are 100 feet deep, that are going down to their deep tunnel system, and they sprayed them with shotcrete 10 years ago. The shotcrete's falling off, so we're talking to them about lining those for them. I mentioned again about the cost. You can see those curves. We know that, as I said, IPR, 90% of what they do is cured in place, so we know when they tell us that at about 42, 48 is where we're cost effective, it's because they're actually bidding the jobs and they know what the costs are, true costs are, but you can see that break is about right there. So we do quite a bit of DOT work, and the dark green represents DOTs where we are approved for use, and we in most cases have a special provision or a standard in place. With regard to Illinois, the material is approved for repairs, they just don't have a spin cast standard. So the Illinois DOT says you can use this, but you got to apply it by hand. And so I'm working with the, oddly enough, it comes out of the bridge office. The bridge, it's a bridge special provision. So I'm working with the bridge people to develop a spin cast standard. But we do have some states like Iowa, nearby states like Iowa and Ohio that actually have centrifugally cast specifications. So if you need a generic specification, I can get you a copy of it. I also have municipal specs too. We're getting this July. We're going to do a big project for the Chicago Water Reclamation District, the Salt Creek Interceptor, which is by Brookfield, and it's a horseshoe, concrete horseshoe, and we're going to line that for them. That's 30,000 feet. They've developed a geopolymer spec on that. We're also doing some work for the city of New York, and they've developed a geopolymer mortar spec. So I do have some municipal standards. We've got one for Minnesota, we've got one for Cincinnati and Detroit as well. So now what I'd like to spend the remaining part of my talk is just going through some projects we've done. I'm going to start with storm applications, and this is a culvert application. And the reason for this trenchless technology is because in many cases it's just not practical to dig and replace. It's either too costly or it's too disruptive. And so this case, this was a 108-inch diameter culvert underneath a one-lane road. It was River Road. It was the only access to a wastewater treatment plant and 2 farms. And there's the pipe there. It's under 20-plus feet of fill. And the other issue here is we had to maintain flow on it. And so we dammed up the end of it, and then we ran an 8-inch line over the road. And you can see that little housing we put on there to protect it, and we were able to maintain traffic on that as well as the flow. And we lined that with 2.5 inches. So you might notice with lining corrugated metal, we still will see a slight profile of the corrugations. It does fill them in, but you'll still see a slight profile. A lot of that's shadowing you see, but so the mannings might be a little rougher. So you just have to be able to account for that in your analysis. This was a storm sewer in California, CMP storm sewer. So you don't see as much CMP being used in storm sewers these days. I ran across one job that is CMP sanitary sewer, and that thing didn't last very long. So that was put in Ohio, next to Middleton, which is where Contech was based. So I guess they convinced them to use metal. That was a bad idea. But these were 48 and 54 inch, and they were underneath a busy intersection, so they didn't want it disturbed. And we could only work at night on this. So you can see some of the restrictions where we could only work during a 10-hour nightly shutdown. The other factor here was the stormwater system drains into the environmentally sensitive San Diego River. It seems like everything in California is environmentally sensitive, but in this case they were concerned about if you used a lining material that could potentially pollute that river because of these threatened and endangered species in it. So that was a big issue as well. So that's what the culvert looked like there, and then here's the crew working at night. And so the crew worked in 2-lane area of the intersection during a 10-hour night shift. And so we ended up spraying 1.5 inches on that. And then they were able to get this road back in 7 days, which was 3 days ahead of schedule. This is another culvert application, and this is probably the worst case scenario for me as far as, this is one that really should have been replaced, but it was, again, underneath the busy intersection, and for whatever reason, this town of Rock Springs did not want this culvert dug up, but you can see how bad a shape it's in. It was full of silt. When we removed the silt, the invert was completely gone. We also had point loads on it. This probably happened during the installation of it. And the other thing we noticed is they were, see the wood bracing, they were trying to brace it to hold it together. So I said this would have been a good candidate for dig and replace, but they wanted this relined, so we went through. Now when the invert's gone like that, we will fill that void and restore the invert with normal grout. The reason for that is our Geospray is 4 times the cost of Portland cement. So we'll use that to fill the voids, and then we'll spray over the top of that. And so you can see the invert's been repaired there. And then we tried to push that culvert back into shape prior to relining it as best we could. That's hence the use of the wood braces. And then that's the first pass of it. This was a pipe arch, and that's what it looks like now. So we were able to get that done under a week and basically put a whole new concrete arch pipe inside there.
Got those together, actually one side of it with that caving in.
Yeah. Yeah, that'd be pretty scary. This is a project in Texas. This is one of the biggest jobs we've done to date. And these were twin 10-foot diameter metal culverts. Each one was 2,200 feet long. And they had been repaired earlier with shotcrete and a bituminous coating. And so that's the shotcrete liner on that, but we found that it was falling and coming off and delaminating, so we went through and removed as much of the loose material as we could. The prep work for this is basically going in with a high-pressure hose and removing loose material and debris. That's all you really need to do. You also have to make sure there's no active infiltration, and you plug joints, and we'll do that as well. But there we are inside it, spraying the inside of it, and then we put 1.5 inch liner on it. On those two. There's another shot of him spraying the inside. So my last storm application, this was an arch, a poured-in-place arch storm sewer. So I assume that this is probably WPA days or before. This is before precast pipe. And you can see these are pretty good-sized arches. And on these, these are in pretty rough shape. So it looks like this was done in 2 pours, the arched top, and then they poured that rectangular bottom with that low flow channel. If you look close, you can see the entire sections of that low flow channel are missing. So here we are, we're sealing a point of active infiltration with chemical grout. But in this project, there was a consultant working for the city of Fort Worth, and he felt that some additional tensile reinforcing was needed. And so here we used mesh steel here and then hand sprayed those corners. And then that crown I showed you earlier, that crown had longitudinal cracking in it, which means that there's some stress cracks in it, and that can cause long-term problems. And so I mentioned that we make a carbon fiber material. We also make a carbon fiber grid. And so what we did is we put a 1/2-inch coating on it, and then we epoxied carbon fiber grid on it. And what carbon fiber grid is good in that it is stronger than steel, and it also will not corrode. And it's thin. So if we went with a steel mesh, that would have been a 4-inch lining and reduced that waterway area. So there's that carbon fiber grid, and then we went through and then lined the inside of that. So we went from that inefficient, deteriorated horseshoe shape to now a round, fully reinforced pipe section. The next few are some sanitary applications we've done. And this was an interesting project with the Cincinnati MSD. And what was challenging about this was there was, in this line that we relined, there was 3 different shapes and 3 different materials in the same line. And this was near the University of Cincinnati, so that it was important that we limited disturbance. So there's the campus there. There's our truck. We just ran our hose down to that manhole. And the first line was this. And I mentioned 36-inch was the smallest. This was a 30-inch line. This is a stacked granite stone sewer from the 1870s. And you can see the jagged edges of the stone. And so they were originally planning to use cured in place on this, but they were afraid it would puncture the bags. And so this is also on a 22-degree slope. So there's one of our workers in there. He drew the smallest straw on this. And he went in there and we hand sprayed that for him. Really had no other options here on this one because of that. So we had that section, and then it transitioned to a brick sewer. And within this brick sewer transitioned down to a smaller size without having a junction or manhole. And so for those of you who have seen brick sewers, those were quite good craftsmen who built the brick sewers years ago, and they could transition and make bends and do really neat things with it. And they would make it hard to do cured in place if you're transitioning down to a smaller size. So that's no problem for us. We just adjust the spray nozzle speed and retraction rate. There's that shot of that poor guy in there spraying that 1/30-inch by hand. And then the last section was a horseshoe shape. And I don't think this is brick. I think this is just a stacked stone again, horseshoe shape. And that's what it looked like after we relined it. So again, we can do, when we're working through that, it's just a couple simple adjustments. So when we run into different, the shape changes or the size changes, it's a simple adjustment for us. That's just showing you a bend that we worked with around that bend very easily. This is a sanitary sewer in Houston, Texas. It was a 72-inch. You can see it was under a highway, 4-lane highway, and it was under 42 feet of fill. This was originally designed and bid as a cured-in-place project. But what happened is, in Houston, in the summertime, it gets pretty hot. The temperatures rose above 100 degrees, and they were concerned that the cured-in-place bags would kick off too quickly as they were wetting out over site, and they were afraid that the temperatures would cause them to start setting up before they got them fully placed inside the sewer. So they went to Plan B, And we offered a value engineering option and using the centrifugal cast process, and there's the sled inside it. And they, as I mentioned, it had been cured in place. They'd already dug the shafts for it, but we didn't need shafts because we just have that hose that goes down. But here he is plugging joints there and points of active infiltration prior to it. The other thing about this project, because I get this question a lot, is why didn't they just wait till the fall to do this? It's because this sewer was in very poor shape and they were concerned about catastrophic failure in some sections of it.
What was the cost differential? Or what has been versus what you did for?
I don't know that, but I can get that for you because I actually have the bid numbers, or our IPR does. I can get that for you. So there we are, getting ready to spray the inside of it. You can see it spalled down to the steel layer in a lot of places, and then there they are spraying it, and then that's what it looks like. Nice ceramic cement finish on the inside. This is, I think this is my last slide for a project case study. This was a sanitary sewer project we did in Texas, and this was also part of a EPA study. And the EPA has a program called the Aging Water Infrastructure Program where they're looking at new innovative technologies, and then they will go out and do a field evaluation. And working with, has everyone heard of Battelle out of Columbus, Ohio? This is a non-for-profit science and technology research group, and they research all kinds of different technologies, and they get involved in the medical field. So they got involved in this as well. And working with the EPA office, we did 165 feet of 60-inch reinforced concrete sanitary sewer. And this required quite a bit of bypass pumping, and we can deal with that. Sometimes the bypass pumping, for those of you who have dealt with us, know it can be most costly part of your project. And you can see how bad that pipe was. It had corroded beyond, all the way down to the steel layer and beyond the steel layer. So it was in very bad shape. It had gushing water coming through it, and then it also, if you look here, this is whole sections of it that were missing. So we will go in and repair those. We'll basically put new steel mesh in, grout, and then we'll spray over the top of it. Do you have a question? No? Okay, you look like you're getting ready to ask me something on it. So that job, we went through and relined it. There's your first pass on it, and then we ended up doing 2.5 inches. And the reason for that is because over half the lining was gone and whole sections were missing. So our calculations showed that we really needed a thick lining on that. And then at the end of the project, this was, has anyone gone to the National No Dig conferences ever? So this, 2 years ago, was held in Orlando. This was a paper given. But you can see at the end of it, the EPA's summary indicated that it was an independent evaluation of technology showed it as a technically viable structural alternative to traditional repair and replacement methods. If you go to the EPA site, you can, and you Google that site or search that site, you can get this paper. I also can get you a copy of it. It's about 120-page paper if you're interested. So, yeah.
So I thought the Geospray was its own structural type when you're all done with it.
It is.
So why do you need to do repair on the existing pipe?
Because there was big voids in it, and you could get infiltration coming through that.
Okay.
So, you know, a lot of times the client wants it. You know, we'll say, you know, we can just spray right over that, but a lot of times the client says, we want you to fill that, you know, fill that void in and repair it.
Okay.
But
You can get a better job, too.
yeah, I mean, that was huge sections of gaps where there's nothing there. So you know, you've got infiltration, you could get piping coming through. So, and you're right, you've got to have something for it to bond or adhere
Right,
to.
you've got to have some kind of a foundation for it to set up so it could last.
But when you mentioned the steel, at that point, I mean, you're almost building a concrete pipe. So
Yeah.
that's what brought the question up.
When we have little tiny repairs, we have a product called Geoplug. It's a geopolymer material. It sets up, it's a very, very fast setting. We'll just trowel that over. But that was, you know, huge sections. And so you need to have something just like shotcrete, you needed something when you go in there with that mortar or that Portland cement, you have something for it to adhere to as you're filling that in on that. So that's the end of my talk. I appreciate your time. I have material here. If you're interested, I have my card. If you have a project or you have an application, all you have to do is email me, give me the size